In this video, we are going to be smacking the moon, orbiting the moon, launching comsats, navsats, and sending the first Kerbals to space. Hello everyone, Karnasa here, and welcome back to Kerbal Gets Real Redux. And I hope you are sitting comfortably, because over the course of this episode, there are going to be 11 launches. Yes, it's going to be a bit of a longer one today, because there was just so much to do in 1957. And of course, it's not just all light satellites, no, we're going to be hitting some pretty big milestones over the course of this year. The first one being sending a Kerbal to space on the new altitude surveillance plane that I have designed purely for this purpose. Whilst at the Space Center at the beginning of this episode, I pick up an optional X-Planes high altitude contract. Having spent nearly all of my confidence at the end of the last episode unlocking faster programs, I really need to get some back. The people are a bit worried about my space program. With the altitude science plane, or the ASP, hopefully my mic picks that up this time, because it does sound like I'm saying something different, but bear in mind I am British, we would say something a little bit different, more like how the Aussies say it. I should be more than capable of breaking the Kármán line as well as going hypersonic. But on the 9th of February, the plane is strapped onto an even bigger plane and ready to be air-launched. This might just be my favourite design for a plane that I have done over the course of this series. I am absolutely in love with how this thing turned out. I thought it looked incredible. And if you do want to get this design, it will be uploaded to my Patreon, as well as all of the craft files from this series. I am uploading every craft that I have flown over the course of an episode every week, so yeah, go check it out if you want to steal them. Anyway, the altitude science plane has two purposes. One, to go very, very high, and two, to go very, very fast. In this first flight though, we are going to be trying to go very high. Now that I've unlocked the X-15 cockpit, I can send Kerbals as high as I want. I am not limited by altitude ceilings anymore. We can send them to space and they won't suffocate and die, which you know is a general win for all parties involved. So 750 kilometers away from the Space Center is where the plane is dropped, and George Edwards is going to be our test pilot for this flight. I really do like putting her into some very dangerous situations. It is a completely untried, untested plane. Who knows what will happen? Well, no, I did test it in simulations and it does work pretty well. Although going hypersonic in it is a little bit toasty. We'll get to that later on. The first configuration of the plane uses two XLR-25s on the back. I've used two to give me a decent amount of thrust to weight ratio on this vehicle, about 0.9 when it starts off. Two of them doesn't just provide a decent amount of thrust though, it also means that I don't really have to worry about finagling where the center of thrust is going through the center of mass. That is definitely something that isn't, say, a problem with the XLR-25, but the Russian equivalent, because that is slightly off thrust vector, so you have to spend ages using RCS Build Manager to figure out where exactly you need to place your engine so it doesn't provide a stupid amount of torque and send your plane spinning off like some sort of demented fidget spinner. With about 340 meters per second of delta V left, I kill the two engines on the back of the plane, and this is going to make me go above the Kármán line. I will hit over 100 kilometers in altitude, which technically does make George Edwards the first Kerbal in space. It doesn't quite hit the requirements for space in real solar system though. In order to breach that, I would have to go to 140 kilometers. But with 337 meters per second left, that is something that we might try and achieve on the second flight of this. George has some absolutely fantastic views of clouds once she breaches the Kármán line though. I mean, look at the clouds, they are incredible. Thanks once again to Ballistic Fox for all the hard work that they are doing on making RSS Reborn. Coming back down though, and going about 2,000 meters per second when I hit 30 kilometers in altitude is a little faster than I would like, but that is definitely the sort of speeds that I need to be going in order to complete the hypersonic contract later on. And this time round, I don't get any heat warnings. I don't have anything heat up, nothing burns off, which is something that I am quite happy about. This plane, once it reaches lower altitudes, flies like an absolute dream though. I have no problems flying this whatsoever, and I have taken all of my knowledge of plane design and implemented it into this vehicle. We have flaps, we have pitch control at the back, very large all-moving control surfaces, and with that I tried to come down for a landing at the much smaller Air Force runway. Unfortunately, I am still going about 200 meters per second whilst I fly over it, so that's going to be a no-go for this time. Even when deploying this plane's secret feature, which is two air brakes at the back covering the engines. I was so proud of this. I thought this looked so cool, using procedural fairing Pacl adapters to make air brakes like that. Unfortunately, it might look cool, but it doesn't work. I did have a look at the aerodynamics GUI later on, and it doesn't provide any sort of braking whatsoever. At least it didn't didn't seem to. So I flew over the Air Force runway and fired up the engines again, just to get me up to speed to try and land at the shuttle runway. And to be honest, I probably didn't even need to do this. But with the flaps helping bleed off as much speed as possible, I come down on the shuttle runway at only 87 meters per second, much slower than I have been going in planes in this series so far. And once again, the air brakes are deployed, but they don't do anything. They just look really cool. And the plane after a short while comes to a complete stop on the runway. George breathes a sigh of relief, having completed the first successful flight of this vehicle. Pushing George over the Kármán line did wonders for her retirement date, and now she is going to be retiring 191 days later. This is great because I do want to keep pushing this back as much as possible. I would quite like her to maybe be the first Kerbal on the moon, but we'll see how that goes. Finally, the Kármán line contract is picked up from Mission Control, and then it's just a quick warp ahead until the administration building is upgraded. Going in, I pick up Katherine Johnson as my chief scientist for that extra integration speed of avionics parts. They tend to be quite expensive, so I thought being able to speed up building those would be a good shout. However, the confidence penalty might be a little bit problematic, as I am really struggling to gain confidence at the moment anyway. With the building upgraded though, I can pick up another program, and the only one that I have accessible to me is early Earth observation satellites, which I grab. It's more money after all. Having now pushed past the age of very light early satellites, I upgrade the Thunderbolt launch complex to be able to build rockets that weigh up to 60 tons, and I have upgraded the Thunderbolt launch vehicle as well. My aim for this is to be able to use it for things like navigational satellites and small payloads that I need to get up to space. This will be the last upgrade of the Thunderbolt launch complex though, as I cannot make it any bigger. I will have to build new ones, but that's what I've got the Odyssey complex for. Then it's just a quick warp ahead to March, where we're going to be strapping Thierry onto the altitude science plane. So the only thing that's going to be different about this flight is the Kerbal that is on board. Thierry Petit, my second Kerbal, will be in control of this flight. I mean, he's no George Edwards, but I still trust him to be able to fly this thing fairly successfully. The aim of this flight is to complete the Kármán line contract, but I would like to go a little bit higher than 100 kilometers. I do have high altitude science on board this vessel, so the higher I go means the more likely I am to be able to complete that scientific experiment. This time round, I burn the engines, leaving only 100 meters per second of delta V left in the tanks, and that is able to push Thierry up to 125 kilometers in altitude. Still not quite going to space as defined by Realism Overhaul, but getting very close. And with only 100 meters per second of delta V left, I'm not actually sure if this design will be able to do it. I will be flying this again though very shortly, just to see if I can just get that last 15 kilometers that I need into space. The plane is able to reach the desired altitude though, and now it's time to come back down, and this time round it's a little bit hotter. I feel going somewhat higher made the trajectory quite a bit steeper, and I did start to see heat indicators come up on the plane, and some of them got very close to looking like things were going to burn off. And when I say things, I mean the cockpit. Being visibly red and having that bar about 4/5 of the way full was quite terrifying, and I'm sure Thierry was most likely himself. But the plane does manage to pull through, and things do start to cool down as we approach the Cape. Once again, lots of simulations were done in order for me to find out the perfect distance from the Cape that I needed to launch this, and it did turn out that 750 kilometers was about the ideal number. Well, 750 kilometers if both engines are to work. If only one of them does fire, then things might get a little bit wet. I didn't mention it in the last flight, but the flaps on the plane are activated as soon as I start descending. I found in tests if I didn't do this, I would descend too quickly and things would burn off. But if I did have them fully deployed, I was able to bleed off speed a little bit quicker, and it stopped this thing turning into a rather messy fireball. Flying over the Cape now, I wasn't really coming in at a good angle to land on the Air Force runway, so once again I'm going to go for the shuttle runway. It is the longest one after all, and this time round I do come down a little bit quicker. Going going at blistering speeds of nearly 120 meters per second when the plane touches down on the runway. Even with those flaps and makeshift air brakes deployed, I wasn't able to bleed off my speed in time. Maybe a few loops around the Cape would have helped, but I just wanted to get this back down as soon as possible. And I know the wheels on this are more than capable of being able to take landing at those kind of speeds. But Thierry manages to bring the plane to a complete stop, and once again this means another complete success for the Kármán Line X-Plane program. Thierry, having never flown anything interesting in his life, adds another 278 days to his retirement date. This means I'm going to be getting him until at least 1962. Well, halfway through 1962. And now with the crewed Kármán Line contract completed, I only have one more X-Plane contract that I need to do until I can complete the X-Plane program, and that is to go hypersonic. I don't think I'm going to be able to do this with the first iteration of the ASP though. It is going to need a little bit of an upgrade in order to maintain those speeds for I think the 3 minutes that contract requires, but there will be a bit of a redesign coming later on. For now, I pick up the optional suborbital X-Plane contract, which will give me more confidence, and it only requires me to go to an altitude of 110 kilometers. We just went to 125, so I am pretty convinced that this will be something that is achievable. The ASP once again is mounted to be air launched. However, neither of my pilots have done the mission training in order for it to be flown, so that is going to have to wait until after Spark 1, which is rolled out to the Odyssey complex on the 6th of April. So what is Spark 1, I hear you asking, and I haven't really gone into it at all. This is going to be my first attempt at smacking the moon. That's right, we are at the lunar impactor era of the save. Okay, so this might seem a little bit weird to veterans of RP1, and it was a little bit weird for me as well, but the launch vehicle that I am using, the Odyssey, is a 180-ton launch vehicle. Now, in For All Kerbal Kind, I did my lunar impactor on a 60-ton launch vehicle. Why does this need to be 3 times heavier? And there are a few reasons for this. The first being fore and aft RCS are no longer available to be used on a science core. In that save, I used a solid rocket and corrected my final trajectory using RCS on a science core avionics probe. Science core avionics are much lighter than near Earth, and it's still going to be the final stage that I use to get this to the moon, because not only are they much lighter, they also use nowhere near the same amount of electric charge as near Earth avionics do. That meant TLI stages in previous versions of RP1 could be so much lighter than what they need to be now. You could still theoretically use a similar design, but you would not be able to fine-tune your orbit and probably would end up missing the moon by quite a way, much the same way that the in real life Luna 1 did. The other reason why this is such a heavy vehicle for this mission is because it's the only vehicle I've got. Rather than designing something else, I know I've got a capable vehicle that will do this. I did in simulations try and use the new and improved Thunderbolt to get this to smack the moon, but unfortunately, due to the pre-mentioned not being able to use RCS, it just couldn't take this up. And one thing that has always been key in RP1, and is probably even more key in programs and launch complexes, is that you really need to be reusing things as much as possible. If I wanted to design an entirely new launch vehicle just for this mission, I would have needed to have built a new launch complex. I probably could have made this a little bit lighter, but the minimum weight requirements on a launch complex would have meant that I could have only made this ever so slightly lighter before having to design an entirely new one, and that then comes with its own problems, such as losing out on efficiency. I wouldn't have been able to build it as quickly as I was able to build an Odyssey. So yeah, using a 180-ton launch vehicle just to send something to smack the moon did seem a little bit ridiculous to me, but I had my reasons, and because this vehicle is so capable, not only will it be able to smack the moon, but it will also be able to orbit the moon as well, which we will see an attempt of later on in this episode. I did say at the beginning we are going to be doing impactors and orbiters, and yeah, this vehicle, the Odyssey, is great at doing both. I spoke in depth about the Odyssey launch vehicle in the last episode because I launched 3 of them and that was all I did in the last episode, so this time around I am going to talk a little bit more about the probe on top. So in order to impact the moon, it does have to weigh a certain amount. It needs to be over 30 kilograms, if I recall correctly, so I did make sure that this did weigh that much as soon as it reaches the lunar surface. Spark 1 doesn't have any solar panels on it at all because they are, to be honest, pretty rubbish right now, and I could make do with the probe core having enough enough electric charge to make the journey over to the moon. It does have a plethora of scientific experiments on board, including a TV camera. That experiment doesn't take too long to run, so I am fairly sure that in the brief period of time that I'm going to be in the lunar sphere of influence, I should at least be able to get all of the high lunar science from that experiment. I was very picky with the experiments that went on board this. For example, I did not put a magnetometer on. That thing takes 30 days. I'm only gonna be in the moon's sphere of influence for about 4 hours because this is an impactor. There is no point getting a tiny amount of science from that on an experiment that weighs a lot and draws a lot of electric charge. No, it would have been silly to include that on this probe. Same with things like micrometeorite detection and cosmic ray science. They take 90 days. No way are they going to be going on this probe. When I get to doing a lunar orbiter, absolutely, those experiments will be really useful then, but not on an impactor. And I want to save as much mass on this as possible because that's just going to make it easier to get to the moon. The Odyssey vehicle does get the probe up to low Earth orbit, just fine, which is great. I didn't have any issues with the second stage, which if you saw the last episode, it was quite problematic. Now, to get me to the moon, I have got one of my favourite engines. It is, of course, the Gamma 2, the British engine, which is the second stage on the Black Arrow rocket. The reason why I'm using this for my orbital manoeuvre is because it has a pretty decent amount of specific impulse in vacuum, and it can be lit in space. It doesn't require ground clamps in order to light it. You also get it fairly early on, but the biggest advantage, in my opinion, that the Gamma 2 has over something, say, like the AJ-10, is you don't need to use high pressure tanks for it. At this point in the game, and to be honest, at every point in the game, high pressure tanks weigh an awful lot more. Their dry mass is a lot higher than the non-pressurized versions, and that means you can get a lot more bang for your buck. It's great. The Gamma is also incredibly reliable. It has something like a 95% reliability chance when you first unlock it, going up to nearly 100% reliability. It is insanely reliable, and as far as I'm aware, and for all Kerbal kind, I've not had a failure on this engine yet. I guess we Brits just know how to make good engines. So because I am playing with Principia, the moon isn't directly aligned with the Cape anymore. That is something that is true without that mod. You can launch due east at the Cape at a certain time of day and you will get a good encounter with the moon. However, because the moon's orbit shifts in relation to Earth, which is modeled with Principia, I can no longer do that. I am using a mod called Lunar Transfer though, and that tells me exactly what time of day to launch so that my apogee, when I perform my translunar injection, will correspond with the ascending node of my orbit, which basically means when I get to my apogee, the moon is going to be there. Now, I could do something like a costly inclination change, but this is much more efficient. Anyway, knowing that I will roughly need about 3,150 meters per second of prograde delta V once in orbit to reach the moon, I'm able to create a maneuver using Principia and get myself an encounter with the moon relatively quickly. All that's required to get a direct impact is just shifting around the time and the amount of delta V used just a little bit. Then it's just waiting for the maneuver node to fire up the Gamma 2. So because Principia maneuver nodes work a little bit differently from the stock game, I am going to be using Mechjeb's complete Principia node feature, which is fantastic if you are playing with that mod. However, this will automatically fire even if you don't have communications, and that is one of the challenges that I have in this series. I must have connection in order to be able to perform a burn. So I wait and see if I am going to have a direct connection to the comnet before clicking that button, because if I click that button and I don't, it will fire anyway and it will do it for me, which I suppose is kind of nice, but I would rather not that happen over this series. But the connection is good and I don't even need to complete one orbit until I get to the maneuver node and the Gamma 2 successfully fires up. Like I said, it is an incredibly reliable engine. I had no worries about this whatsoever, but let's face it, I've not had the best of luck with this run so far, so it could happen. The burn is done to completion and I do have a direct impact course with the moon. I, however, don't quite like the angle that I'm going to be arriving at the moon, so I do change this ever so slightly with the onboard RCS. This is why I said you might need RCS for these kind of designs. With the moon set to be hit, I decoupled the top probe. This is the science core, and the reason why I do this is because the avionics on that Gamma stage are just too power hungry. I would not be able to power that all the way to the moon. I would run out of electric charge way before we arrive. Now, because I have force percent set to 0, to try and avoid changing my trajectory as much as possible, it does get a little bit weird and starts clipping back into the Gamma stage. So I time warp through the vast majority of this in the hope that it corrects itself and I don't come out of time warp and the entire thing implodes. Luckily, it does correct itself after a little while though, and I am able to kill warp. Now it's just a few days journey to the moon, but before we get there, I have an X-plane to fly. So I come back to the Space Center and pick up early human spaceflight era electronics research as well as science, before once again again strapping George Edwards into the altitude science plane, whilst we have our probe on the way to the moon. So this flight did not go as anticipated, and when trying to fire up the two XLR-25s, one of them did fail. It was a little bit of foreshadowing earlier on when I showed the plane splashing around in the water like me without armbands on. Unfortunately, when flying this craft, I needed both engines to ignite for this to be able to successfully get back to the Cape if I set the distance to 750 kilometers. The plane just didn't have enough thrust to get that far if one of the engines failed. And also, I was no longer firing through the plane's center of mass, so I'm probably getting some losses there too. I do, however, burn the remaining XLR-25 to completion, which is seriously overburning it. Considering both of them firing at once is just about the limits that they have, yeah, it's like double the amount that this engine really should be running for. Luckily, it does not explode though, but I only get to about 40 kilometers in altitude. Really nowhere near as high as I wanted to be going. And because I didn't get very high, well, I didn't go very fast either, and my max speed was only about 1,520 meters per second, some ways off what I did need in order to get back to the Cape from the position where I dropped this. This is always a problem with test flight, it can always come and hurt you, and now I was very worried whilst I was flying this. This plane was designed to be landed on a runway, not in the ocean. Every so often I would keep checking my map view to see if I was going to be anywhere near close to the Cape, and the answer was a resounding no. So I was going to have to put this down in the sea, and hopefully not kill anyone, well, George, whilst doing so. George, however, being the expert pilot that I do have, is able to bring the plane down at about 60 meters per second. Still incredibly fast when I do hit the water, and the plane does do a bit of amateur acrobatics, doing a somersault, a flip, but no barrel roll, but it does come to a rest, and the only damage to the vehicle is the two engines on the back. That's all that I have lost. That could have gone so much worse. A redesign of the altitude science plane is going to be needed, but now it's time to go back to Spark 1 to see it hit the moon. Having spent about 3 days on its journey, the probe finally arrives at the moon. This was a pretty quick transfer, and that's another nice feature about the lunar transfer mod. You can actually set it so that you can get to the moon faster if you want to. This does mean that you will be burning a little bit more delta V, but considering we're not aiming to slow down at the moon once we arrive, we're just aiming to smack into it as hard as possible. I don't need to slow down in any way, so I can spend a little bit of extra delta V whilst I'm at Earth to get me to the moon quicker. This does also mean that I don't need to put as many batteries on this thing, although I did still put more than enough for a 6-day trip to the moon. In fact, I think this probe could have lasted about 90 days if I wanted it to. Armed with a TV camera on board, we get some absolutely fantastic shots of Earth's closest neighbor that is sent back to the smart people over at Mission Control, and they can analyze with a bit more clarity, having close-up images, just exactly what the moon is made out of. We have some good idea, but this will certainly help. As we near the end of the probe's life, the moon gets bigger, and it gets even bigger, because of course it's getting closer. We do have a direct impact course, and as I hit the moon, the game crashed. Because the game died, unfortunately that meant that I did not complete the impactor contract. I did, however, complete the flyby, but there is a bit of a fix for that. The all-powerful cheat menu. A quick hop into there to complete the contract brought up the second newspaper clipping, which funnily enough showed the instant that my probe hit the moon, so it was somewhat aware that I had completed this contract. It just didn't complete when I came back to the game. Completing those two contracts gave me 75 free applicants though, and what I have tended to be doing over this series is whenever I get free applicants, they go straight into my researchers. A little bit like I did in Legacy RP1, whenever I gained a free point from getting over 20 science, that went straight into my science. It has been working out somewhat nicely for me, with my total researchers now up to 625 and my total engineers up to 400. And with there being 11 launches in this episode, I don't really think I need many more engineers than that currently. Hitting the moon did garner me quite a bit of science, so I go into research and development and pick up primitive solar panels. Yes, I didn't realize the cavemen were running around bashing each other with photovoltaic cells. Clearly I missed that history lesson. I also picked up 1960 orbital rocketry for some better engine choices, digital communications, which is going to allow me to finally build relay networks, and basic avionics and probes, which will make my avionics lighter and more efficient. After this, it was a quick warp ahead to June, when the next Odyssey rocket was finished. Building these in only 60 days now does mean that I am going to be getting a lot of use out of them. On the 19th of June 1957, Constellation IV is ready to be launched on top of an Odyssey launch vehicle, and this is going to be an attempt at getting a first communication satellite in low Earth orbit. Once again, a 180-ton launch vehicle might be a bit overkill for this, but the Thunderbolt wouldn't be able to lift what was required, especially as the payload requires a ComSat payload of 80 units. That stuff is quite heavy, and you need to do some maneuvering in space in order to get to the required orbit. Getting an apogee above 2.5 million meters and a perigee above 850,000 meters isn't really possible directly upon launch. On a rather cloudy and dismal day that very much reminds me of the view outside of my window, the rocket is launched. The satellite on this is just going to be a basic communication satellite. I don't even get to keep this once the contract is complete, so I made it as bare bones as possible. It's just a Gamma 2 stage that I used to get to the moon with a communication satellite on top of it. Setting ascent guidance to have an apogee of 1,000 kilometers meant that I knew that I would be able to have my final perigee of above 850 kilometers. All I would need to do is one quick burn with the Gamma once in orbit to raise my then perigee to an apogee of over 2,500 kilometers, satisfying all of the contract requirements. At least that's what I would have liked to have happened, but once again test flight ruined the Russian rocket interceptor second stage, and this spun out of control and was deemed a failure. Things really have not been going so well this episode. We've had 5 launches so far, and 2 of them have had test flight failures. Those are not good odds. However, back at the Space Center now, I decide to rework the altitude science plane into its second form, the beta iteration, this time round using the XLR-99, the engine that the X-15 did use. This will definitely be able to get me to hypersonic speeds and even higher than 140 kilometers. It's all tooled and built up, ready to be flown later this year. In order to get that done a little bit quicker though, I do rush the hangar. Now, ordinarily, I wouldn't rush anything, especially launch complexes. If you rush a launch complex, you don't gain any efficiency, and that is really bad in the long term. Like, seriously, don't do it. However, because the hangar is always at max efficiency, I didn't think this would be too bad to do. The only problem that you run into when rushing the hangar is that it makes it a lot more expensive, in that you are going to be paying your engineers that you have allocated 1.5 times more than you would normally. I felt this was somewhat a reasonable sacrifice in order to get this built before the end of this episode though. Lots of building in this Space Center section though, as I go and design and tool the newly built Thunderbolt 4. With the launch complex now complete, I might as well start building those as soon as possible. This does however mean a little bit of a shift around of my engineers, because I need some in that complex in order to start building those rockets. So in order to get over this, I hire some more. Now being at a total of 520 with 700 researchers. My human resources department is really starting to get a little worried with the size of the space agency that I am building. Don't worry HR, it's only going to get bigger. But finally, the next Odyssey is ready to be launched, once again trying to get a communication satellite up into orbit. So on the 27th of August, the next Odyssey is fired up, and this is exactly the same as the last launch, except hopefully this time it will work. I need to put a ComSat in low Earth orbit, and damn it, I will get it done by the end of this episode. A little bit of a clearer day this time round. Hopefully that means that we won't suffer any problems. I'm sure it was those pesky clouds that got in the way of the last launch and caused that failure of the second stage. I mean, they're not related at all, but it would be pretty cool if inclement weather events did affect test flight. I know with newer versions of BlackRack's volumetric clouds, there are thunderstorms. They haven't made their way into RSS Reborn yet, but it would be very cool to see some lightning as I am attempting to launch. I know that rain has now been added, but it would be nice to see some lightning every now and then too, so I can say that all famous line, try SCE2 orcs. It certainly would provide a little bit of a dramatic flair. I did reply to a comment in the last video asking me about how I use Mechjeb ascent guidance. I was asked to maybe do a tutorial on it, and I said I'm not going to do a full video on that, but I will talk a little bit about it during this next Kerbal Gets Real Redux episode. And whilst we're waiting for this to get to orbit, if it does, that's what I'm going to talk about. I'll have it come up on the screen and I'll tell you the settings that I use in order to launch these automatically. That being said, I still haven't messed around to see if you can use ascent guidance to launch unguided upper stages. I really need to get to doing that. I just have not had the time. Okay, so this is your ascent guidance window, and if yours does not look like this, there is probably a very quick fix. See that button at the bottom that says Primer Vector Guidance? Performance RSS RO, well, you want to select that. It's a drop-down menu. All you need to do is click on that. I'm not sure what the stock system is called, but there should be 3 options that you can click on at the bottom of that screen. And the one we're going to want to use is Primer Vector Guidance. Once that has been set, Mechjeb Ascent Guidance should look a little bit more like this. Target periapsis and target apoapsis should be pretty self-explanatory. That's the altitude that your final orbit will be. The number that you set in there will be your final perigee or apogee. Attach altitude, I never really mess around with, but what that does is sets the altitude where your burn will finalize. I guess it could maybe be useful for doing things like geostationary transfers, but I've never messed with that, and really I don't think it's that necessary. Booster pitch start is how fast you're going to be going before the pitch program kicks in. For higher thrust launch vehicles, you tend to want to have a lower number, maybe 40 to 50 meters per second. For something that doesn't have quite as much oomph, maybe between 80 and 120 meters per second. The booster pitch rate is then how quickly it will turn. I've got it set to 0.6 degrees per second here. Once again, you can just fiddle around with this until you find a nice rate that the rocket will turn that gets you into a good orbit. Higher thrust vehicles should have a faster pitch rate, whereas lower thrust vehicles should be the opposite. Q trigger, I've got no idea what that does. I assume it's something to do with max Q. PVG after stage, I very rarely turn this on. I think I've turned it on maybe twice in my entire time using this, and that just sets a stage where the pitch program will start. Might be useful if you've got an uncontrollable solid first stage. And then really the final thing is fixed coast length. I have this set on to 0 seconds so that my rocket does not coast at all. At this stage of the game, it tends to be that my engines only have 1 ignition, so I don't want there to be a coast stage. I believe you can also turn it off just by clicking that button. Below that is just the status, and it gives you the numbers that tell you how well your ascent might be going. This can throw errors sometimes, but usually you don't have to worry about that. One thing I've said before is if you have about 800 meters per second remaining on the top number, which is indicated by the number in the brackets, that should be a decent amount of delta V to get you to orbit. This can change though depending on the design, and that's really it. It's really simple. There are options that you can turn off and on as well, such as automatically deploying solar panels and antennas, whether it warps, which you really shouldn't need to click if you are doing a PVG ascent guidance, and hot staging. Mechjeb ascent guidance will hot stage for you. But yeah, that's basically it. So Constellation V was able to get to orbit. Now I just need that Gamma 2 engine to fire up once more in order to get this into its desired orbit, because currently it is way too low. Without Principia, I would normally just do a burn once I reach my apogee, but because Principia is a tad more finicky than the normal stock maneuvering system, I do create a maneuver, and one that is going to burn the Gamma to completion, or 2,267 meters per second of delta V. This will put me way above the parameters that the contract requires, but I thought I might as well just burn this thing to completion, as long as it didn't go interplanetary, which it won't, because 2,267 meters per second of delta V is some way shy of escape velocity of Earth. Thankfully though, the Gamma 2 does indeed fire and burns until it is out of fuel, putting me in an incredibly elliptical orbit, but one that is capable of completing the contract, which happens, and then the satellite is handed over to the customer, and I lose this forever. With that out of the way and 1959 orbital rocketry unlocked, yes, in 1957, the second iteration of the Odyssey vehicle is all tooled up. This vessel is, however, a little bit larger and requires different propellant than the first design, so unfortunately that does mean I need to modify the launch complex. That will only take 8 days though, so it's not the end of the world. Having now also unlocked digital communications, a tracking station upgrade is on the cards, which I purchased pretty much immediately after unlocking that technology. That will really help when attempting to communicate with probes at the moon, which for now have just been impactors, but very shortly I will be attempting to put a permanent satellite there. Well, as permanent as Principia will allow. After this, it's a warp to October, where the second iteration of the ASP is now built and ready to be flown. Now donning the more powerful and efficient XLR-99, the Altitude Surveillance Plane Mark II has almost 700 meters per second more delta V than the original variant. This means it will be able to go much higher, and having a thrust-to-weight ratio of over 1 when I first fire up that engine means that theoretically I could just point this straight up and burn upwards. But that would be rather silly, because I wouldn't gain anywhere near the speed that I would require to get to higher altitudes. The aim for this is to push this into space as defined by Realism Realism Overhaul, that being over 140 kilometers. And this certainly can do it, especially with a tried and tested pilot such as George at the helm. So the XLR99 is a lot more thirsty than the two XLR25s I was using on the previous iteration of this plane. And because of that, I was really struggling with finding space to actually store all of the fuel. I couldn't put some gigantic fuel balls on this, that would have made it rather unaerodynamic. In order to get around this, I didn't do anything like part clipping, no, but I did raise up the utilization of the wings. So the wings themselves do carry quite a bit of the fuel that this plane is going to use. I keep nearly calling it a jet. It's not a jet, it's a rocket plane. With nearly 3,800 meters per second of delta V, when first flying this, the plane can confidently go hypersonic for the duration that it needs to, as well as reach never before seen altitudes by Kerbal kind. The flight profile I took for this mission was to pretty much immediately pitch up as soon as the plane was air launched. Absolutely no wasting around, but it wasn't a rather aggressive pitch up to begin with. I did maintain somewhat level flight for the first 10 seconds or so. As mentioned, this can go straight up and still gain speed, but that's probably not the most efficient way of doing it. Getting a little bit of horizontal speed first would be ideal. However, I never pushed the pitch past 45 degrees. That is the max that I will take this plane to. When I tried simulating this, I found this was really the sweet spot that made my trajectory go high enough that I would break into space, but not so high that when I came back down again, the plane melted. That X-15 cockpit is great for getting to altitudes, but it's not so great at surviving re-entry. Unfortunately, before I start designing any space planes in this series, I am going to have to unlock space plane level technology. The heating that you encounter when you re-enter Earth's atmosphere is just going to be far too deadly to do anything before that tech is unlocked, and that is going to be a tech that unlocks quite a lot later down the tech tree. That is absolutely something I do want to be doing in this save though, is space planes. Plus in the old Kerbal Gets Real I did design a couple there, so I thought it'd be nice to return to them at least at some point. Not for a while yet though. Anyway, the engine is completely successful, burns to completion, and George Edwards is put up to an altitude of 151 kilometers, some 10 kilometers into space. Not only will this get me some more science by running a crew report at space low, but it will also complete a few milestone contracts. George gets some absolutely fantastic views of the Earth, being the first Kerbal in space. Although obviously she's not going to stay there for very long, because this is on a ballistic trajectory and we are coming back down almost immediately. In fact, she only manages to spend less than 2 minutes in space, so really, in order to get a Kerbal to stay in space, we are going to have to design something a little bit better. But this design works perfectly for the X-Plane program, and I mean, I didn't even really need to do this. I've already completed the Kármán line contract earlier on in this episode, which is all that I needed to do to complete that program. This was just to gain a bit of extra confidence and reputation. But with dizzying heights achieved, it was now time to bring the plane back down, and once again I launched this 750 kilometers away from the space center, knowing that this was about the required distance in order to get back safely and land the plane on the runway. I have not mentioned it for a few episodes, but if you do land these planes on the runway, if you have picked up an X-Plane contract, you do gain a little bit of extra reputation. And I mean, I'm not going to say no to that. Flaps fully deployed to try and bleed off as much speed as I possibly can whilst coming back into the atmosphere. I am going very fast coming down. I also did have a bit of trouble pitching up the nose, and maybe if I had a higher angle of attack, I would have been able to bleed off a little bit more speed, rather than going about 2,400 meters per second at 40 kilometers. Yeah, this was quite dangerous and the plane did start heating up, but thankfully nothing did burn off. It always is a massive worry when the cockpit heats up, especially when I have got my first Kerbal to go to space on board. But the plane pulls through the worst of it, and I accidentally overshot the space center ever so slightly, but still going about 1,400 meters per second, I am not worried, and we can turn this plane around to get a nice landing on the runway. George manages to line up with the runway from quite a distance, this time going for the space center runway rather than the shuttle one, just because it was how my trajectory was all aligned up. However, once again, I was coming down a little bit too fast, and I did touch the runway at 100 meters per second, which is quite a bit faster than I would have liked to have been going, but the plane is able to slam on the brakes and slow down way before it ends up shooting off the runway, which has happened in this series before. Another successful flight of the altitude surveillance plane program, and George Edwards once again can breathe a sigh of relief as she is not turned into a Kerbal marshmallow. Putting George in space puts her over time back by nearly another 100 days. She is a very famous Kerbal now. She has made it to space and come back unscathed. There is one more high altitude flight that I do want to attempt before finishing this program though, because I unfortunately did not quite manage to get all of the high altitude science. I am 0.6 off, and that 0.6 can really make a difference, he tells himself uncertainly. There is also one more X-Plane suborbital contract to complete, which I do pick up, before heading back to the Space Center to fly the newest iteration of the Thunderbolt launch vehicle. So on the 11th of November 1957, the new Thunderbolt is ready to be launched, with Nav-1 its payload on top of the vessel. And this will be my first attempt at sending a navigation satellite up to low Earth orbit. It is a contract that I picked up, and one of the ones that is required to complete early commercial satellites. Very much the same as the commercial satellite that I launched earlier on in this episode. As soon as I complete this contract, the satellite that I send up will disappear. I won't get to keep it, I won't get to use it for comms, so I've basically made the payload on top of this as small and bare bones as I possibly could get away with, and that is why I'm able to launch this on a Thunderbolt launch vehicle, or at least a new Thunderbolt. Now the only thing that remains of the original Thunderbolt in this vehicle is the diameter of the rocket and the color scheme. Everything else has been changed completely, and because of that I can now launch much heavier satellites to low Earth orbit using this vehicle. Gone is the RD-101 first stage. That has now been upgraded with an LR-89, the engine that I am using as the Odyssey boosters. This way I'll get even more data from these, flying these a lot, and it also meant that I didn't have to buy any new expensive engines for the first stage of this vehicle. The second and third stage though aren't new engines, but I haven't used them an awful lot. I have once again turned to the Gamma series of engines, and because they are the same engine, the Gamma 8 and the Gamma 2, I'm fairly sure Test Flight models their reliability as 1. So because I already have some reliability data from the Gamma 2 by using it to go to the moon earlier on in this episode, the Gamma 8 on the second stage of this will have a bit of reliability data too. So gone now is the rather wacky XLR stage, and I no longer have a solid kick stage on this vehicle either, and so because of that I can use Mechjeb ascent guidance to get this to orbit. Well, maybe I can with solid kick stages as mentioned earlier on in this episode, but I still have not checked that out. So the upper two stages for this vehicle are quite similar to something I have used before. If you have seen my For All Kerbal Kind episodes, this is nigh on identical to the Black Prince launch vehicle that I was using there. The only difference being I was using an RZ2 engine on the first stage, which is the British variant of the LR-79. It's identical to that engine even, the Brits just took the design from the Americans. The Americans gave them the design for the LR-79, which they used on the Blue Streak rocket. Instead of the LR-79 for this though, I've gone for the LR-89. As mentioned before, I've already bought it and I do have some reliability data for it, so that made the most sense to me. In order to complete the first navigational satellite contract, I needed to have a perigee above 350,000 meters. This vehicle does not have relightable engines, so I need to make sure that my orbit is perfect when I launch it. Now, I did test this in simulations many times before even rolling this vehicle out to the pad. I tend to do that. You should always test your vehicles, otherwise you are just wasting a lot of time. What's the point in launching a vehicle that you don't know if it can work or not? That was one of my many tips that I said in the old series. Always test your designs, and then in the old series I ended up not testing designs and killing Kerbals. Hopefully none of that will happen this time round. But yes, it does mean that I have to hit that orbit from launch. And I put in the values that I required in Mechjeb ascent guidance, and lo and behold, I was perfectly able to get that orbit with a little bit of delta V left over. I went for a 375 kilometer orbit rather than the 350 that it requires because I am playing with Principia, and that does mean that my orbit will shift. I tend to find in low Earth orbit it shifts by about 5 to 10 kilometers. So if I got a 355 kilometer orbit, there would be a chance that my orbit would actually dip below the contract requirements and I wouldn't finish the contract. It is an additional challenge that I am going to have to overcome with Principia. It doesn't model decaying orbits, but it does model other celestial bodies having influence over your vehicle, so your orbits will shift ever so slightly. With all three stages having successfully fired, and knowing that the Gamma 2 is a rather reliable engine, I had no worries that this was going to get me into the orbit that I required in order to complete that contract. And finally, after nearly 7 minutes of ascent, the Gamma 2 shuts down with 312 meters per second of delta V left. I clearly overbuilt this thing, and puts me into the required orbit to complete that contract. It's just a short 2-minute wait to check that the orbit doesn't decay, and with that, the navigational satellite is handed over to the customer and I lose it. But at least I completed the contract. With the first navigational satellite contract now complete, I am able to pick up a navigational satellite network and a communication satellite network too, because I finished the communications network earlier on. I'm not going to be picking those up yet though, that will come in a future episode. This one is already long enough. I do however cancel my next lunar impactor contract because the Spark that I'm currently building is more than capable of just getting to the moon. It is going to be a first lunar orbit attempt, which will come after the next launch, because right now I have one final X-plane altitude contract to complete, and with a short amount of training, Thierry Petit is ready to fly the altitude science plane. And once again, it's just going to be a case of trying to push this as high as I possibly can. I've already gone into space with this plane, I know that it can do it, and the next contract, and the final one in this series of contracts, only requires me to go to 120 kilometers. At least if my memory serves me well, this is the final one. There might be another one that I try and attempt in the next episode, but I need to review the footage before talking about that. But exactly as it did last time, the XLR-99 fires up and burns to completion, although this time round I do leave a little bit of fuel left in the tanks, and therefore I'm only going to be getting to 139 kilometers with this flight, and that means Thierry is not going to space today. But he will be getting pretty high, and as he has not done as exciting missions as George Edwards, I'm fairly sure that this will still push his retirement date back by quite a bit. Anyway, he reaches the rather lofty altitude of 139 kilometers, and this is where I realized that maybe I should have waited a little bit before flying this mission, because the weather around the Cape currently is less than ideal. It is a very cloudy day indeed, and that means I have no idea where the Cape is. Now, I can check the map view to try and find it, but it's not as good as being able to visually see it. Don't get me wrong, the clouds from RSS Reborn are absolutely fantastic, but in this case, they are proving to be a bit of a thorn in my side. And this is not the only issue that I have with this mission. Coming back down through the atmosphere, I am going a little hot, and things start to heat up considerably. I'm not entirely sure why this happened, considering I didn't go as high this time as I did with the last flight, but things are looking very bad for Thierry Petit. With a little bit of rolling around of the plane, I do manage to prevent the cockpit from overheating and exploding. However, this does unfortunately mean that I rip off the flaps. Them being fully extended for the duration of the descent of this flight clearly was too much for this design, and they broke. Not to worry though, because as we saw with the last flight, this plane can still safely land at above 100 meters per second, which I'm fairly sure I will be able to go when I reach the runway, if I ever do. Yes, unfortunately, as I said, the clouds were getting a little in the way. It did mean that I could get a few nice beauty shots of the plane coming down through the clouds, however I was some way off the space center, and only having 233 meters per second of delta V left, I wasn't entirely convinced that I would be able to get there. So that means it's time to try and put this plane down in a field. Local Florida man reports large winged alligator landing in his swampside shack. In reality, no, it's just a multi-million-dollar X-plane. Once I'm through the cloud cover, I found a suitably flat area to bring this down. Now, unfortunately, because I hit the GUI whilst I was filming this, I don't know exactly how fast I was going when I touched down. I just know it was slightly less than 125 meters per second, because that's the speed I was going about 5 seconds before the wheels touched down on the marshy Floridian ground. The air brake and brakes are deployed, and Thierry Petit is brought safely back to the surface, although a little far away from the space center than I would have liked. Getting Thierry really high pushed his retirement back by 139 days. Clearly, my space agency's drug policy is a little different from real life. 5 days after his landing, the next Spark mission, inventively named Spark 2, has all been built up and is rolled out to the launch pad. However, before flying that mission, a couple of things are needed to be done first. I go into mission control and pick up the hypersonic X-plane contract. As soon as I have finished that, I can complete that program. I also quickly nip into the spaceplane hangar because I broke off the flaps in the last flight, and those need to be replaced before finally training up George Edwards to be the first Kerbal to go hypersonic. She really is starting to get a whole list of achievements under her belt, and then I guess, yeah, it's time to do a lunar orbiter. On the 30th of November, for the 4th time this year, the Odyssey complex once again comes to life. This time, Spark 2 is the vessel on the pad and its mission to attempt to send something to the moon and stay there, rather than just flying by and hitting it rather spectacularly. No, I want to orbit the moon because there is an awful lot of science to be gained from doing that. Just doing a lunar flyby means we're only going to be in the moon's sphere of influence for a limited amount of time. If I can get an orbit, well, that means we'll be there for a lot longer. But not permanently, because Principia will have other things to say about that. Thank you, orbital decay. Anyway, the launch vehicle used for this mission once again is just going to be an Odyssey vehicle, the same one used for a lunar impactor earlier on in this video, except this time the payload is a little larger. Well, I say the same vehicle, but actually it has been improved thanks to the acquisition of some lovely new orbital rocketry engines. Originally, the Odyssey vehicle was a Super Atlas with a rather weird Russian interceptor second stage. That crazy Russian stage, however, now has gone and has been replaced by an LR-91, the engine used on the second stage of the Titan launch vehicle. And because of that, this vehicle is much more efficient. The LR-91 has a lot better specific impulse in vacuum than the SR-155 did, which was the engine used previously. There aren't really many drawbacks from using the LR-91 over the original Russian interceptor design. The main one I can think of being the LR-91 is not relightable. I'm only going to get one use out of this engine once it fires up. However, that doesn't really matter as I never relit the SR-155s anyway. And to be honest, the way I go about designing craft in Realism Overhaul for the most part, until I do unlock engines that do have relightability, is that I build an engine for every stage that I'm going to do. That's pretty much my design ethos when going in and building something, is thinking I need this specific engine for this specific part of this mission. So because I do that, relightability isn't really a feature that I am needing at the moment. It can be nice for certain missions and probably is almost certainly required for later on missions that I will be attempting over the course of this series, but for now, it's not a big issue. Okay, so Spark 2 made it to orbit just fine, and right now I probably should talk a little bit about how I am actually going to orbit the moon with very limited deep space avionics, or no deep space avionics if I'm going to be honest. I haven't unlocked them yet, and that means I'm going to have absolutely no control once I reach the moon, which you may think, well, that's going to be quite difficult getting an orbit around the moon, but fret not, there is a way that we can go about doing this so that I don't actually need control once I leave Earth's sphere of influence. And it is a technique that I have used multiple times over multiple launches to the moon. It's not the last time I'll be using it in this series, and probably not the last time that I'll be using it in, say, other series like Kerbal kind as well, because that is something I'm going to be doing in my next episode of that, which will be coming out this weekend. Anyway, the pivotal key for that is going to be spin stabilization when I'm at Earth, but let's not talk about that until we actually get to that. Right now, I am using Principia to plot out my maneuver to the moon. And after a little bit of wiggling around with Principia's built-in maneuver editor, I get myself a nice encounter with the moon that will just fly past it. I'm not aiming for the lunar surface this time. No, I don't want to crash into it. We want to fly past, and we want to activate the one solid rocket engine that is going to be on the spacecraft once it arrives at the moon. In this case, I have gone for a Baby Sergeant, and that's because it is a vacuum optimized solid rocket engine and it doesn't weigh an awful lot. Now, I can fling quite a bit to the moon using this, and this probe does have all of the latest and greatest experiments. So once I'm at the moon, it will hopefully get me a rather large amount of science points. But anyway, that lovely maneuver that I just created to get myself a rather nice flyby of the moon was not going to be sufficient. Unfortunately, when it came to doing the burn, I was over the north coast of Australia, where there are absolutely no comm stations whatsoever. Having not yet set up a communications satellite network, this means that I had no way of talking to this probe. So what to do? And the answer in this case is to replot the maneuver, wait another orbit, and hope that when I get to that maneuver this time round, there is going to be a communications ground station underneath me, so I actually have control over this vessel. And did that happen? Would you believe it? No. Fortunately for me, I built this design with this limitation in mind, and that's one of the reasons why I am actually sat in a parking orbit of 300 kilometers rather than the usual 180 that I would go for. Having a higher altitude means that I am more likely to be able to connect to a ground communication station, something that I so desperately want right now. The other feature of this design is that it does have enough electric charge on the vessel to remain in a low Earth parking orbit for about a day without me really having to worry that I am going to run out of electric charge. And this is definitely something that I am going to utilize, as I have to wait several orbits before my maneuver finally lines up with a ground communication station. But anyway, 8.5 hours after launching this probe, I'm finally able to get good communications back to Earth over my maneuver node, which currently is sitting just above Madagascar, and the Gamma 2 thankfully fires up. It is of course a very reliable engine. I had no worries that this stage was going to fail. When I said this had a day's worth of electric charge in low Earth orbit, I did get that a little wrong. It's actually more like half a day, and I've used 8 hours already, which means I only have 4 hours of electric charge left. That, you might be thinking, is nowhere near enough battery power to last me all the way to the moon. But that is also something I do not have to worry about, because the main draw of electric charge for this design at the moment is the near-Earth avionics unit on the stage that is currently propelling the spacecraft to the moon. Once that burn is done and I have separated this stage, there is only going to be a science core on the vessel, and that has a lot less electric charge draw. The probe that will be orbiting the moon does also have solar panels, and that combined with the much less power usage means that this probe will last indefinitely, or at least until the solar panels degrade to a point where they're no longer producing me enough electricity, or until the craft goes crashing into the moon due to precessions in lunar orbits. Yeah, there's a lot of things that can make this mission end early. Anyway, with the encounter for the moon now all completed, with a slight adjustment made using RCS on the TLI stage, it is time to figure out how on Earth I'm going to capture once I arrive. And this is incredibly important to do whilst I'm still in Earth's sphere of influence, because as mentioned, I do not have any control over this vessel once it reaches the moon. I need to plot out my maneuver now and point the spacecraft in the right direction and hope that it remains that way by the time I get to the moon. Now in stock KSP this would be very easy, because as soon as you start time warping it completely kills all of your momentum. That is not the case in RO, because persistent rotation is a thing that we have to deal with, and especially with Principia, which makes it even worse to deal with. I will spin out of control before I reach the moon, and I will lose my attitude way before arriving at the moon. There is a way to get over this though, and I mentioned it before: spin stabilization. Much like a round from a rifle maintains its attitude once leaving the barrel, I'm going to spin this once I'm pointed where I need to be, so that the spacecraft remains pointing in that direction and doesn't change its course. Once this is all done, and only a slight amount of spin is needed here, you don't need to go crazy at all, then I can decouple the top stage, and I completely lose control over this. The only thing I can now do with this vessel is fire up the solid rocket engine on the final stage. That's it. I do not have any other control whatsoever. But that's fine, because that's all I need to do. And the perks of this are a science core is really light. I can make them really small, and they do not use much electric charge at all. But anyway, with the craft all spun up and decoupled from the TLI stage, it is on its way to the moon. Upon arriving at the moon, thanks to the magic that is spin stabilization, the spacecraft is still pointing in the right attitude to capture at the moon using the one single baby sergeant on the back of the probe. Now I've created a maneuver for this, partly to know where I was going to be whilst I was still in Earth's sphere of influence, and partly to figure out roughly what my orbit will be once I fire up this solid rocket. As it is a solid rocket, I have no control over it. Once it fires, then it's done. I can't stop it mid-burn, which is why when I was designing this, it was kind of pivotal to make sure that I didn't overburn this stage. Otherwise, this will just become a slightly more expensive lunar impactor. And then even if I do hit the moon with this stage once it's fired up, I won't even complete a lunar impactor contract, because unfortunately I will have taken my speed required down below the contract requirements. Anyway, I fire up the baby sergeant once I hit my maneuver. A good thing about Principia is that you fire up the engine once the maneuver hits. You don't have to divide the burn time by 2, nothing like that. I I much prefer this way of doing it because it means I don't have to do any quick maths in my head. And yes, I do know there is an extended burn time indicator in the game, I'm just too lazy to turn it on most of the time. Once the baby sergeant has burned to completion, which really doesn't take a long time at all, I am left in a lunar orbit of 52 kilometers by 8 megameters, which unfortunately is too high for me to satisfy the requirements of the first lunar orbit contract. This is a little bit annoying, as in tests this did work, but when I did it for real, it didn't. So I am going to have to go back to the drawing board for this and maybe figure out a way that I can have slightly more delta V once I arrive at the moon. Ideally, I would also have my Peraloon a little bit above 52 kilometers because that is quite low. And now, a major problem with Principia that I have already mentioned about the moon is because this orbit is so elliptic, this is not going to last long at the moon at all. In fact, I'll even show you the entire duration of this mission around the moon. Because to be honest, I didn't have anything better to do at the Space Center right now. I do have another ASP flight that will be coming after this mission, however I need to wait for training to happen first. But yes, not even after 6 days after I launched this probe, it goes crashing into the moon's surface. Now you can get stable orbits around the moon, and if you want to know what they are, I would recommend looking up frozen lunar orbits. There are 4 inclinations that you can be at the moon that will mean that you will stay, well, quite a long time in orbit. The only ones that I know for certain are 86 degrees and I think 24. I said for certain and then I said I think. It's 24, 26, 28, somewhere around there. And if you have a spacecraft in that inclination around the moon, then your orbit really won't change an awful lot. It will still, and if I ever want to do a lunar space station in the series, which is something that I am considering doing, it will be a little bit tedious. The reason being is that I'm most likely going to have to make station keeping adjustments. Otherwise, the crew that are on board that space station might end up crashing into the lunar surface, which really would not be ideal. One of my aims for this series is to try and kill as few kerbals as possible. I haven't killed one yet. Let's see if we can keep it that way. Anyway, killing kerbals aside, the spacecraft ends in a rather explosive manner, and Spark 2 was not the massive science haul that I was hoping it was going to be. Once again, we return to the Space Center, and after a quick warp to the 12th of December, George Edwards finishes her training yet again to fly the ASP. And even though Spark 2 did not get as much science as I would have liked, it still gained me quite a lot. I have 54 science points, which goes immediately on early human spaceflight materials science, early flight control, and human-rated EDL, because at some point I am going to want to send kerbals up to space to stay. And you know, it would be nice if we could also return them in one piece. Anyway, with George all trained up, it's time to launch the last mission in this mammoth of an episode. And this flight is going to be a tad different from the previous X-Plane flights that have happened in this episode. And for that reason, I'm only sending it 500 kilometers away from the Space Center. On the 12th of December, George Edwards once again mans the mighty ASP, and this time she is not going high. We are not going to attempt to send her as high as we possibly can. No, the aims for this X-Plane is going to be going as fast as possible while still in the low atmosphere. That's right, this is going to be the last contract that I need to complete in order to finish the X-Planes program. We are going to be sending a Kerbal hypersonic. Now that means I need to be going faster than 2,000 meters per second while still quite low in the atmosphere. It has to be below 40 kilometers. 2,000 meters per second at that sort of altitude is going to get really hot. If I go slightly faster than that, the entire plane will melt and, well, we will lose George Edwards, and that would be very bad. So this really was a little bit of a fine balancing game, trying to get the speed that I needed to go without pushing it too fast. Now, I'm quite fortunate that the XLR-99 that is powering the altitude surveillance plane is deeply throttleable. That means I can kind of fine-tune my speed as much as I want. But the first thing that I'm going to do for this flight is fly up as high as I can without going above 40 kilometers. There's less air up there and things won't heat up as much. If I was trying to go 2,000 meters per second sub 20 kilometers, this thing would be more burnt than my toast this morning, and trust me, it was not a pretty sight. After a short climb at about 31 kilometers, I hit the all-important 2,000 meters per second speed mark. At the same time that the heat warning indicators on the plane come up. Already, I am a bit worried, and I need to maintain this speed for 2 whole minutes. Upon reaching 2,200 meters per second, I bring the throttle almost down to completely off, and then I do kill the engine because it is just speeding up. Even with a deeply throttleable engine, that engine is so powerful that it's just not going to slow me down enough. So now, rather than just being a game of finely tuning the throttle, it's going to be turning the engine on and off, and on and off, hopefully being able to maintain over 2,000 meters per second this entire time, and also hopefully not melting George. And after what felt like the longest 2 minutes of my entire life, I finally passed that mark while still going above 2,000 meters per second. It was quite fortunate because I had also run out of fuel by this point, so if I needed to go any faster, I would not have been able to. Because I didn't go so high this time, it also meant that I didn't go quite as far, which is why I did put the plane at 500 kilometers away. And even still, I did overshoot the Space Center ever so slightly. But still going at speeds of around 1,000 meters per second whilst I was at 20 kilometers in altitude, I knew that I would be able to turn this plane around and land it on the shuttle runway as the flight was intended. And that's exactly what I do. Once again, we line up very nicely with the runway, this time not landing in some random field, thankfully, and the plane touches down at about 100 meters per second and does a rather alarming wobble when it does, but very quickly George is able to take control of the beast and make sure that it doesn't roll and blow the entire thing up. Once again, another successful flight for the X-Plane program, and now with that contract completed, that program can be finished. I, however, don't finish the program yet because I am still gaining money from it and I would like to carry on gaining money. Plus, there is an additional hypersonic contract that I do want to try and at least attempt in the next episode. So I am going to keep that for now. Then it's just a warp ahead to the 24th of December where the tracking station is upgraded. After this, which I'm not going to show you because this episode is already ridiculously long, I went into the vehicle assembly building and constructed a better, improved lunar orbiter that we hopefully should see in the next episode. Because now we find ourselves on the 1st of January 1958. What a year 1957 was. 11 launches. This video is the longest video I have ever made by quite a considerable margin. It's at least double the length of any video that I have ever done before in Kerbal Space Program anyway. Some of my Dyson Sphere Program videos were about an hour long. And I know this episode has taken a lot longer to come out than I initially planned. I was only going to have a week off over Christmas, but because of just how long this one turned out being, it meant that I had to keep pushing it back. And then For All Kerbal Kind started again, and I have been working on that this past couple of weeks and expect to see my next episode out this Sunday. And talking of Sundays, Sundays is when I used to release these. I am now thinking of changing that around a little bit because For All Kerbal Kind is now back and one of my Sunday slots has to be dedicated to that. I think these are now going to come out Friday nights instead, which is when this video hopefully should come out. I'm recording the last of this voiceover on the Thursday. If it's not out tomorrow, something has gone terribly wrong. I am going to still try and stick to a weekly schedule, but as these episodes are getting a lot longer, well, I might not be able to do that. I might not be able to edit and do everything over the space of a week, whilst also having to worry about For All Kerbal Kind, and there is definitely some Kerbal Space Program 2 content that I want to be doing as well. I want to get back into the modding scene for that, and I want to cover some really cool mods that are coming out for the second game. But yes, I am going to try to stick to a weekly upload schedule on Fridays now. And if for whatever reason I can't get the episode out in time, I will be updating my YouTube community page. So if you see a post from me on there saying that Kerbal Gets Real Redux is not coming out this week, well, you heard it from there. Anyway, next time, expect more lunar orbiters, the end of the X-Plane program, a dive into commercial satellites, and preparing for the first ever interplanetary mission. A big thanks to Redstone Wizard, Shadow Dev, Y Mandarin, Darth Malachor, Moss Config, Mr. Blue Star, Ryan Miller, and the rest of my patrons and members for their continued support. I have been Carnassa, and I will see you later.